So as I was saying in our last video, before I was so rudely interrupted by the timer on that one, so sorry, this was going up, then it's going down, so there's only one turning point, and the degree is always one higher than the number of turning points. So the degree for this one would be 2, and then if you notice here, it ends on a negative note, so my leading coefficient would be negative. Okay, leading coefficient, negative. So for this next portion, you've actually done just about all of this before, but you've done them for graphs that look like these, where we have found the maximum and we have found the minimum before. When they opened down like this, it was a minimum. And then we've also found the intercepts. Same steps that we've done before. The only difference is that if this was what we had in the past, where it was just a parabola, now you might be able to find the local minimum and the maximum. If you had a graph that looked like this, your local maximum would be that point up, that point up there. And then this would be a local minimum. Local is actually old school. Now, new school, if I upgrade my language, I apologize, like saying fresh. It's a relative maximum and a relative minimum, because it's relatively true. So what we're going to do here on your wonderful handy dandy calculators, so grab those if you haven't already, find the relative maximum, relative minimum, and the zeros of the graph of the function. So the zeros, remember, are the same thing as my x-intercepts. And then everything else is going to be kind of the same. So here's your equation, f of x equals x cubed minus x squared minus 9x plus 9. And then you're going to first go ahead and graph that into your equation. So graph, then y equals, and then you're going to need a pretty good window. So I'm going to give you the window, noting that you can adjust them on the positive side and on the negative side if you need to. But on your own right now, what I would love for you to do, please, is to graph this, and most of the standard window works. You can go by ones, negative 10 and positive 10. And then negative 10 works as well for a y minimum. But for your max, in order to see what the actual maximum is, I'm going to tell you to go ahead and type in 20. And you can go by 2s or you can go by 1s. So take a moment, press pause, and enter this into your graphing calculators right now. And then hit graph. Okay, so if you plugged it in correctly, then you have the same exact graph that I have right here. And we're going to find a couple things. The first thing I'm going to have you find is your relative maximum. So just to point to it, your relative maximum is this point right here. When you do set up your boundaries, make sure your left boundary is to the left of it and your right boundary is to the right of it. So if this is essentially what we're looking at, it's probably the best graph that I've ever done. And here's your maximum. When you're setting up your boundaries, just make sure that your left boundary and then your right boundary, are actually pointing to where the point is. Do that for me. You can also follow these steps, but if you need to, we'll do it kind of first together. So following my script here, kind of. Second, trace. And the first thing I'm going to look for is the maximum, so I'm going to hit number 4. And then left boundary, here I am. I try to just get to where my cursor is at the top of the point, and then I'm going to move a little bit to the left of it and then hit enter. Do the same thing, go, go, go. Here's my cursor at about where it is, and then I'm going to move it to the right from there and then hit enter. And then my guess is anywhere in the middle. And I get my maximum is negative, or relative maximum, because there's not really a maximum because this goes on forever. The relative maximum is negative 1.43, comma 16.90. Cool. Take a moment, press pause, and do the same thing right now with the relative minimum. Okay, did you do it? And if you did, you would have gotten 2.10 and negative 5.05 for your minimum. And then if you look at this, there are 3 x-intercepts, 1, 2, 3. So you're going to calc 0, so second trace, to find the 0, number 2. And then I'm just going to go from left to right so I can keep track. I'm going to hit enter for my left boundary. Then I'm going to move my cursor to make sure that it's to the right. And then hit enter again for the guess. My first 0 is negative 3, 0. So 0, negative 3, 0 is 1. And then you'll do the same thing again for the next 0, which we see here. And then, so go ahead, press pause, find the other two. But I get 0, 1, 0, and I get 3, 0. All right. Great job, beautiful people. Thank you for joining me, and have a delightful day.